First of all, we'll understand what is electronics. Electronics is a branch of engineering that deals with current conduction through vacuum tube, gas, or semiconductor material. It means if the current is passing using the medium as vacuum tube, gas, or the semiconductor material, then that we are considering as electronics. We also have seen the shops which are written as electricals. So what is the basic difference between electrical and electronic that we will understand now? Electrical. Okay. The electrical means if the current is conducted through a conductor. If the current is conducted through conductor, then that will be considered as electrical. And if the current is conducted through vacuum tube or gas or semiconductor material, it will be considered as electronics. So there is a thin line difference between the electrical and electronics. In electronics, we are using electrical signal to give the input to the devices, because without power, no one can work. So we have to give some power, and for that we are using electricity so that our electronic instruments works properly. Now, if you will break this word electronics, okay, you will find it is combination of two words, electron plus physics. And we know what exactly is the physics. Physics is study of the physical behavior of different things. Okay, physics is nothing but studying the physical behavior, how physically any particular material behaves. And here in electronics, what we are going to study is we are going to study about the behavior of electrons. Okay, that's why from electron plus physics, it became electronics. So we are going to talk about the physics of electrons. Physics is the behavior, physical behavior. So if we will summarize and we want to understand the definition of electronics, then we can easily understand that in electronics, we normally study the physical behavior of electrons, how the electron behaves. That we are studying in electronics. Now, when we are talking about electrons, you need to understand also what exactly is the electron. So normally the materials are having electron, proton, and neutrons on their nucleus. Okay, they are having different number of atoms, and atoms are having this electron, proton, and neutrons. Now, how the electronic component looks like? So you can see from the diagram that these are the electronic components like resistor, capacitor, inductors, integrated circuits, diodes, LEDs, etc. etc. Yeah. Coming to the next, as I told you about the electricity. Electricity is what? Electricity is movement of electrons in a conductor material. So when under a conductor material, some electron moves in the opposite direction of that flow of electrons, the current starts flowing in the circuit. Okay, always remember that suppose you are having a iron conductor or copper conductor, you are passing from one place some particular force, and because of that, the electron starts moving from right to left. Suppose the electron starts moving from right side to left hand side. Now, because of the movement of these electrons from right to left, the current will start flowing in the circuit from left to right. So if the electrons are flowing from right to left, the current will flow from left to right. The signals are very much important, and as I told you earlier that whenever we are using these devices, these electronic devices, when we combine multiple components together in a circuit, then these electronic devices requires some electrical signals, some energy. Okay, and accordingly, there are two types of electrical signals that we can use for electronic components, and those signals are AC and DC. Okay, AC stands for alternating current, and DC stands for direct. AC is alternating current, and DC is direct current. As the name suggests, alternating, it means alternately it changes. What does it change? It changes the direction of the flow of the current. Okay, so accordingly, in direct, there is no change in the direction of the flow of the current. So here there are two types of signal based on how they behave, how the direction of the signal is, AC and DC. In alternating current, the signal changes its direction. In direct current, there is no change of direction. You can see the diagram now. The first diagram that you can see is a DC current, and you can see the electrons are flowing, or you can say the current is flowing in a single direction under DC. Okay, the flow is in one direction. At the same time, when you will see the AC signal, alternating current, for some time the current is flowing from or you can say in the clockwise direction, and then after the current is flowing in anti-clockwise direction. So the current which is flowing for some time in clockwise direction and then after in anti-clockwise direction is considered as AC current. So DC flows continuously in one direction. AC signal changes its direction after a certain time of instant. Similarly, at the bottom, when you will see the bulb which is glowing, in case of AC, when we are applying the voltage, the current, for some time the bulb is glowing, and then after the bulb is in off condition. The second diagram you can see of bulb, it is getting yellow, it means it is glowing, and then after it goes into off condition. At the same time, in DC, the bulb glows continuously, although it is not mentioned using yellow in the diagram, but you can see that because the current is constantly flowing in the same direction, it is not changing the direction. You will get always the light from that bulb. But in case of the AC signal, it is in on and then it is in off condition. Normally at our home, the power supplies that you are getting, from those power supplies, you all will get the AC signal, alternating current, the second one wherein your bulb is glowing in on and then in off condition. Okay, so that type of the signal normally we are getting at our home. So you will ask me a question maybe that, sir, that you are saying that at our home we are getting AC and which changes its direction, and because of that the bulb that you have shown here on the PPT, that is getting on and off alternately, then why we are at our home, why the bulb is not blinking continuously on and off, on and off? So that is because the frequency of the signal. So here in electricity, in alternating current and direct current, the term frequency is used. And what is frequency? A complete cycle at one particular second. How many cycles are completed? What is cycle? One positive half and one negative half of the signal. Let me annotate something so that I can explain it to you. Like this is your signal. Okay. Here the signal is like this. AC signal is like this. And then after reaching to this point, it changes its direction like this. Okay. So this is called as positive half and this is called as negative half. Now, from this particular point to the end point of this signal, when it completes one positive and negative half cycle, this is called as a complete cycle. And in one particular second, how many cycles a signal completes, that is called as frequency. At one particular second, how many positive and negative cycles are completed by the signal, that is considered as the frequency. So the normally at our home, the signals that we are receiving from electricity department is having 50 hertz. It means 50 positive halves like this and 50 negative half like this. So total 50 positive and 50 negative halves. It means, in other way, if I'll say, then in 1 second, the bulb that you are using, is getting into on condition for 50 times and into off condition for 50 times. It means in a second, your bulb is getting on 50 times and then it is getting off. Your eyes are not that much capable enough to differentiate between that on and off 50 times in a second. And that's why we feel like the bulb is glowing continuously. But exactly the bulb is getting on and off 50 times. Now you will say, sir, in case of the DC signal, when we are getting the continuous input, while in case of the AC signal, we are not getting the continuous input, why we are making this AC signal? Why we are using this AC signal and why the electricity board is sending that signal, which is not continuous? Continuous means which is not giving me a regular output. My devices is getting on and off 50 times in a second. Why this type of signal are being sent? So the reason is, when we are generating the signal from natural resources, normally the 60 to 70%, or you can say 80-85% things, when we are generating the signal, they are having two directions, positive and negative half. So when the signal is generated, the signal is generated itself in terms of AC. We can generate DC signals also. And to generate the DC signal, we need to use the chemical reaction, the concept of chemical reaction. We need to use the batteries. And then from the batteries, we can store the energy and we can use it. So we are converting the AC into DC, storing in the battery, and then we are using it or elsewhere using some chemical reaction inside the battery, we are generating the DC signal. Now consider you have n number of devices at your home. Now you don't want to get the AC signal. You want the continuous single direction output. Then you need to use the battery. How many batteries you need to use at your home to run your daily devices like your fridge, TV, oven, fans, ACs, etc., etc. The requirement will be too high. The second problem, after a certain time of instant, when that chemical reaction will end, then that battery will get dead and then you cannot do anything. You have to replace that. So or elsewhere you have to use some particular type of the battery which can store the energy, which is not generating the energy, but which can store the energy. Again, you have to have a large number of batteries. So that is the reason, by nature, when we are generating the electricity or electrical signal, it is in the form of alternating current. And that's why the electricity board is giving us the alternating current. Now, how to eliminate that problem? Using different type of the devices which are available in electronic circuit, using those devices, this on and off problem of the AC signal is also eliminated. Okay, so we have different circuits that we can make, and using those circuit, using the electronic components, we can make those circuits, and using those circuit, this negative half problem or direction change problem of AC signal can also be eliminated. So when I'm using the word circuit, you need to understand what exactly is the circuit. So circuit is a complete and closed path. Circuit is a complete and closed path which electric current, where electric current can flow. In other words, if you want to say, then you can say circuit is something which is closed and allows the electricity to flow through it. Normally, whenever the circuit is closed, the current can flow through that. And if the circuit is open, then current can't flow through that. Remember, always very important point. If your circuit is open, no current flows. You can see the diagram here. Okay, this is your battery, this is your switch, and this is the bulb. Okay, now here this switch is in open condition, it is not closed. So your circuit, although the devices are connected, but the circuit from here to here, there is no connection. It means the circuit is open, and like this, one part is connected, another is not connected. So in this type of the circuit, the current cannot flow. At the same time, if the switch will come into the closed condition like this, the second diagram, then the connection will be like this, wherein both the terminals of that LED bulb is connected through the battery, through the power supply. In this particular situation, the current will flow and your bulb, now here it is glowing. Always remember, if your circuit is open, no current flows. If you close the circuit, then immediately the current will start flowing in the circuit. Okay, that's why I'm giving you another example. Many of the time, I'm not saying that don't obey your parents, I'm just giving an example. Many of the times it happens that we are charging our cell phone. Okay, and when we are charging our cell phone, we are keeping the adapter on the socket, and then we are connecting our cell phone through the type C or any other type of the cable from the adapter. And then when we start the switch, your mobile phone will start charging because the circuit is closed. So the energy from that particular switch will start coming towards your mobile phone, and the mobile phone's lithium battery will start saving that in the form of energy inside it so that you can use it later. Now, when you remove your cell phone, the switch is on, and if you remove your cell phone, C-type cable, if you remove, then although the switch is on, no current will flow in the circuit. The current flow will stop immediately as you open the circuit. It means, suppose you are going to your village and by mistake you kept your charger in on condition, mobile phone charger in on condition. So you will think, yeah, now this is going to cost me money because it will consume electricity. No, it will not consume electricity. Simply, if there is some LED display on your charger, then that may consume electricity. But it is simple normal charger. It will not consume electricity until something is connected. So the open circuit, no current flows. Closed circuit, current starts flowing. Coming to the next. What is the force because of which the current starts flowing in the circuit? And accordingly, when we had read the definition of electricity and electronics, we said that if it goes through a conductor, then it will be electricity. If the current flows through vacuum tube or gas or semiconductor, it is electronics. So what is that which because of which different component differs? This is conductor, this is insulator, this is semiconductor, and based on that the electrical or electronics is coming. So what is that driving force? That driving force is called as resistance. Resistance. And resistance is an electrical quantity that measures how the device or material reduces the electric current flow through it. It means the resistance is nothing but an internal strength of the material because of which it can resist the flow of current inside it. In other words, if you will take some example, suppose I am having electricity signal, I am applying that signal to wood. Okay, dry wood I am having, one at one particular end of that wood, one wire, and at other end another wire. Now if I'll touch in between the wood, I will not get shock. Now replace that wood by iron rod. Don't try it. If you touch, you will get shock. Now some material, partially dried wood. Okay. Some other type of material like partially dried wood. It is not wet कि अभी अभी काट के पेड़ है, वैसा नहीं है जिसमें गीला होगा लकड़ी, और इट इज नॉट फुल्ली ड्राइड कि पूरा सूख गया है लकड़ी, partially wet. Okay, now if you will connect do the same experiment, you will get shock, but you will get less shock. Why? Because वो पूरा गीला नहीं है. So now the wood will behave like an insulator when it is fully dried. It will behave like a conductor allows the current to flow if it is completely wet. It will not, or you can say partially allow the current to flow through it if it is partially dried or partially wet. Okay. So the internal strength inside every particular material, there is an internal strength, and that strength resists the flow of the current, and that strength is called as resistance. The resistance is measured in ohms. Very important part. Wherever you need to limit the flow of the current in the circuit, it may happen that you're making some circuit, and at some particular part you require more amount of current, at some particular part some particular component require less amount of current, and you need to limit that current. How to limit? So for that we are using the resistances. Now you can see the animated diagram. It talks about the resistance. You might have understood seeing the diagram that boy can punch to first two but can't to third, because the third one was having more strength than that boy. Okay. Now the second diagram, if I'm using some insulating material, even though I am applying the energy, the current cannot flow. But in place of that, if I'm using some conductor material, the current will flow. Now the semiconductor allows partially, like I'm giving just an example. Whatever I'm saying right now is only to explain. It is not 100% correct, but this example will explain you the resistance clearly, and also semiconductor, conductor, and insulator. Suppose you are applying 10 ampere of current. Suppose you are applying 10 ampere of current to a material, and from one side you are applying 10 ampere, from other side the flow is happening or not, that I don't know. From other side, when you are measuring, you are getting 0 or zero point 0.1 or zero point 0.5 or very nominal 0.07, like that ampere of current. 10 ampere you are applying at the second end, other terminal you are getting 0 0.7, 0 0.8 or 0 or 0.2 or 0. Then it will be insulated. Why? Because that material has higher strength and it can resist all the current to flow through it. It stops all the current to flow through it. It will be considered as insulator. Okay. It means the resistance of that particular material is very high. That's why it can stop the current to flow through it. Okay. The second part, I'm applying 10 ampere current. I'm measuring at the other terminal and I'm getting 9.7, 9.8 or 9.9 or 10 or 9.1, like that. Now here only a partial amount, 9.8, 9.9, only 0.1, 0.2 is eliminated. Then it means that that particular material has high resistance. No, that material has very low resistance, and that's why it allows majority of the current to flow through it, and you are getting out of 10 you are getting 9.8, 9.9. So resistance is low. Earlier case resistance was high, now resistance is low. Third case, you are applying again the 10 ampere, and from the second terminal you are getting 4.5 or 6 or 5 ampere of the current. So partially it blocks some part of the current and allows the remaining part to flow through it. It cannot stop fully the entire current, or it is not allowing fully the entire current to flow. So it is not stopping as well as not allowing. This type of the material is called as semiconductor materials. Okay, so there are three types of materials. Normally we you all might be aware. uh, uh, Many of the times student ask some question Like, sir, water is what type of thing? It is conductor or insulator? Yes, water is conductor. Okay. So पानी अगर है तो आपको करंट लगेगा. Now, फिर वो पूछते हैं कि सर सपोज देयर इज अ बिग पॉन्ड, एक तालाब है, और उसमें अगर सपोज 440 वॉट का वोल्ट का वायर था, वो टूट के गिर गया, क्या होगा? द आंसर इज वेरी सिंपल. इट डिपेंड्स. सपोज यू वांट टू चेक, और you are also there inside the that pond. It depends how much far you are from the point from where the current starts flowing into the water. So the connection point between the water and the cable, where you are, how much distance you are, depends upon that. If you are very nearby, then you will get shock, more quantity. If you are very far, then you may get nominal feel that कुछ तो हो रहा है, करंट जैसा लग रहा है, क्या मालूम ये है कि नहीं. Okay, so if you are very close, you will feel the current. If you are very far, you will not feel the current. Why? That is a conductor, so it should offer the flow of electrons, but the pond is too big. Internal resistance of entire water, whatever is there in gallons inside the pond, that will be too high, so that it will stop the current to flow through it, although that material is your conductor, because the size of the pond is very high, very big. So that's why the total resistance will be more than whatever. At the same time, suppose that cable is of 2,50,000 volt in place of 440 volt, then definitely you will get shock. So, sorry, it depends. Now moving ahead, whenever we are connecting the devices, we can connect the devices in series or in parallel. And there are different ways. You need to only understand this thing, because I may use the word, it is series connection, it is parallel connection. Okay, so you need to understand about the circuit, what is series and what is parallel. See the first diagram. Okay, the first diagram, there are two LEDs which are connected. LED bulbs दो आपको दिख रहा है. Okay, now you can see when the switch is closed, the current is flowing through first bulb, and then after to the second bulb, and then after again in this direction it is flowing in parallel. If you see at the meeting point here, the current which is flowing in the circuit is divided into two parts, and then at the same time both the bulbs are glowing. Okay, so you can see the bottom diagram where R1, R2, R3 are written. The first diagram, in this particular, one terminal of the first resistance or the component is connected to the other terminal of the second component, and the second terminal of the second component is connected to first terminal of the third component. Now this type of connection is called as series connection, wherein the current remains the same current is flowing. Okay, but the voltage drop across the components, the voltage between R1 in between R2, in between R3 will be different, and that total voltage of the circuit is V. So V is equals to, suppose voltage at R1 is V1, voltage at R2 is V2, and voltage at R3 is V3. So V will be V1 plus V2 plus V3, but the current will remain the same. Now here in this second connection, you can see the terminals are tied together. Like the first terminal of R1 is connected to first terminal of R2 and first terminal of R3. Similarly, the second terminal of R1 is connected to second terminal of R2 and second terminal of R3. So now in this particular arrangement, if you are making, you can see the current which is flowing till this point, this particular point, it is same. And then after it is divided into three parts. So the currents which are flowing is I1, I2 and I3. So current is dividing. And voltage between these two terminals, ye or ye, the voltage between these two terminals will be equals to V. So this type of connection is called as series, and this type of connection is called as parallel connection. Now we'll talk about the basic components that we are using to make any particular circuit. And these components are battery, resistor, this is resistor, LED, push switch, rocker switch, preset resistor, LDR, toggle switch, battery snap, transistor, slide switch, integrated circuit, etc, etc. So these are the components that we are using. Now coming to those components one by one. Resistor, just now we had talked about the resistance, the device, the component, the material which offers a resistance is called as resistor. The value is measured in ohm. It look like this. Okay. Now it is very difficult for people to know what will be the value of the resistance. So for better understanding of human beings, the value of the resistance, the resistor when they are made with different color codes. Just like you can see on the screen, different color codes. Based on those color codes, the circuit offers different type of resistances. Okay. So keep keep the resistor on your hand, and always remember, keep the resistor on your right hand, and keep the resistor in such a way that the colors which are very near together should be at your left hand side. The direction should be left hand side, and there is a huge difference between, like you can see, small difference, थोड़ा थोड़ा डिस्टेंस में है ये, और यहाँ पे बड़ा डिस्टेंस. सो ये आपके राइट हैंड में यहां से पकड़ो, और ये आपका लेफ्ट हैंड साइड का डायरेक्शन होना चाहिए. एंड देन find the color of the first, second, third and fourth band. Accordingly, you can measure the value of the resistance. Okay. So इसको हम resistor बोलते हैं. Different colors at different band has different unique values, and accordingly we are calculating. Like for this particular example, I will share with you some details also later on the group. In this particular example, it is red, second is also red. Okay. So in first band red means 2. Second band red again means into 10 raised to power 2. Okay. And then after third band is green, that is into 10 raised to power 5. And then the fourth band is gold, it is tolerance plus minus 5%. So from first and second band, if it is similar, so it is 2 and 2, 22, 2 and 2, 22. Third band is green here, so into 10 raised to power 5, 22 into 10 raised to power 5 is the value of the resistance in the ohm. In this way, we measure the value of the resistance. 22 ओम किलो ओम का ये रेजिस्टर है. Okay, now moving ahead. Capacitor. A capacitor is a component that stores electrical energy and then discharges. Like I had explained you कि आपका जो बल्ब है घर का वो 50 बार ऑन एंड ऑफ होता है, but because from our eyes we cannot differentiate 50 times on and 50 times off in 1 second, so it is quite normal for me, but actually the bulb is getting on and off 50 times. If you want to eliminate that type of problem, then what you can do, so simply you can have a capacitor. So what does the capacitor will do? When the negative, when you will connect into the circuit, the capacitor is having the capacity to charge itself, to store the energy for some time. So it will hold the energy for some time. So during the positive half, the capacitor will get charged, and during the negative half, the capacitor will give the entire energy. So during positive half, you are giving the energy to the capacitor. During negative half, the capacitor will give the energy to your circuit. So in place of getting your device on and off continuously 50 times in a second, your device will continuously work. Okay. Different type of the capacitors. You can see these type of material if you will found in any of the circuit, that is a capacitor. The measurement, the unit of the capacitor is farad. Okay, so ये ऐसे दिखता है, इसको हम कैपेसिटर बोलते हैं. Okay, it stores the energy inside it. One more thing that I want to tell about the capacitor is that capacitor stores the energy. So you will say, sir, why we are using batteries? And we should store the energy using capacitor. This question will come to your mind later on if you read. Okay, why we are using battery? If the capacitor is having the capacity to store the energy inside it, and you may or you may not get the answer on Google. The answer is the capacitor has the capacity to store the energy, but when it discharges, it gives all the energy whatever it has stored to the circuit. So whatever energy your capacitor is having, the entire energy together will be thrown out at that moment. Okay, so जितनी एनर्जी उसने अपने पास रखा है वो पूरी एक साथ दे देता है. तो पॉजिटिव हाफ के टाइम पे उसने एनर्जी को स्टोर किया, नेगेटिव हाफ के टाइम पे पूरी एनर्जी को दे दिया. अब नेगेटिव हाफ और पॉजिटिव हाफ खत्म होने के बाद कैपेसिटर डिस्चार्ज्ड है, उसके अंदर कोई ताकत नहीं है. Again, when the positive energy will come, it will charge, and during negative, it will discharge. So it gives all its energy at the same time. जब आपको जरूरत पड़ी तो पूरी की पूरी देगा. वो ऐसा नहीं दे सकता है, वो ऐसा नहीं कर सकता है कि यार I have 100 rupees. If you need, I will give you entire 100 rupees. It cannot do like now you take 10 rupees. Later on, I'll give you 10 rupees. Then later on, I'll give you 10 rupees like that. It cannot do. Entire 100 rupees. If you ask, give me money, it will give you 100 rupees fully. Now, the battery is not like that. The battery gives you as per your requirement. So when you charge your phone for 1 hour, after 1 hour, the battery gives you the output throughout the day and night. Okay, so that's why we are using battery in place of capacitors. Now the inductors are like, looks like resistor, but it is not resistor. Many student confuse between the inductor and resistor. Inductor is like a coil. Inductor is like a coil. You can see, even if you will see your fan, okay, the fan is moves because of these coils. It is sometimes called as coil also. Okay, so the inductor is a passive electronic component which is capable of strong electrical energy in the form of magnetic energy. Okay, basically it is used a conductor that is wound into a coil, and when the electricity flows into the coil from the left to right, this will generate a magnetic field in the clockwise direction. So to generate the magnetic field, the electrical coil or the conductors are wounded, and that winding is called as inductors. You can see these type of inductors are available in the market. Okay, coming to the next, diodes. Okay, let me check after diode how many things. Okay, last topic for today, because it will take time. Diode are basically the made up of semiconductors. The semiconductor materials are divided into two types: intrinsic semiconductor and extrinsic semiconductor. Intrinsic and extrinsic. Okay, intrinsic is what? Intrinsic is something which is in its purest form. And extrinsic is what? When we add some impurity, then it is called as extrinsic semiconductor. Okay. Many of the times, many materials are in its nature form, they are intrinsic, but to improve the quality of that particular material, we need to add some impurity into that. Like suppose you're buying a paint. दिवाली अभी गई है, घर पे पेंट वेंट किया होगा लोगों ने. Okay, so if you are buying a paint from, let's consider the oil paint you're buying from some hardware shop. When you are bringing it to your home and you want to paint your wall or something, then you need to add some thing like some thinner or something like that. We are adding into the paint because the paint is very मतलब बहुत गाढ़ा है. And if you will try to put that paint, then it is maybe आपको लगाने में डिफिकल्टी हो, और मे बी वो थोड़े दिनों बाद पपड़ी बन के वो निकल जाए. सो वो पेंट जो है वो प्योर है, बट उसको हम डायरेक्ट अप्लाई नहीं कर सकते हैं. उसमें थोड़ा हमको इम्प्यूरिटी मिलाना पड़ता है. सो डिफरेंट टाइप ऑफ इम्प्यूरिटीज आर अवेलेबल फॉर डिफरेंट टाइप ऑफ मटेरियल. तो पेंट की जो इम्प्यूरिटी होगी, थिनर होगा या कुछ और मटेरियल आता होगा. कई जगह पे लोग कैरोसिन को यूज करते हैं मिक्स करने के लिए. सो वो कैरोसिन आपने मिला दिया, एंड देन आफ्टर उसको थोड़ा डाइल्यूट कर दिया, जो थिकनेस थी उसको थोड़ा डाइल्यूट कर दिया, और फिर आप यूज कर सकते हो. सो पेंट तो पेंट था, और पेंट का काम था कलर लगाना. बट क्योंकि वो बहुत ज्यादा गाढ़ा था, उसकी प्रॉपर्टी को चेंज करना जरूरी था. अगर वैसे ही आप यूज करोगे तो आपका पेंट जो है वो निकल जाएगा बहुत जल्दी. सो उसकी प्रॉपर्टी में थोड़ी सी चेंजेस हमने लाई, तो वो पेंट बहुत दिनों तक यूज किया जा सकता है. Similarly, keeping that in mind, we may need to change the property of the semiconductor material, and based on that the intrinsic and extrinsic semiconductor came in the market. Intrinsic is extremely pure in nature. Extrinsic, if we add impurity into the इंट्रिंसिक सेमीकंडक्टर, दैट इज कॉल्ड एज एक्सट्रिंसिक सेमीकंडक्टर. ओके, अगर हमने पानी मतलब ऑयल मिला पेंट में, केरोसिन मिला दिया तो वो एक्सट्रिंसिक हो गया. अभी एक्सट्रिंसिक इज मोर बेटर फॉर अस. Okay, so similarly, when we talk about the extrinsic, it is adding impurity into a pure semiconductor. There are two types of impurity that we can add. One type of first type of impurity is called as p type impurity, and second type of impurity is called as n type impurity. Okay, when we put one p type impurity, it forms a p-type conductor. When we put n-type impurity, it forms n-type semiconductor. Now, what is p-type impurity? The materials which are having 3 electrons at its outermost orbit. The materials which are having 3 electrons at its outermost orbit is called as trivalent impurity. The materials which are having 5 electrons at its outermost orbit is called as pentavalent impurities. So ये impurity हो गया, उससे हमने material बना लिया p type और n type. आपको वो पूरी कहानी से मतलब नहीं था, आपको p type और n type से मतलब था. So कहाँ से आया वो मैंने आपको एक इंफॉर्मेशन दिया. नाउ p type सेमीकंडक्टर हो गया ये, और ये n type हो गया. दोनों को हमने पास में लाया और बाहर से हमने बैटरी लगा दी. ओके, सो बाहर से हमने ये बैटरी लगा दी. सो बैटरी लगाने के बाद ये जो मटेरियल है वो इस तरह से, होल्स फ्रॉम पी टाइप विल स्टार्ट मूविंग टुवर्ड्स कैथोड एंड इलेक्ट्रॉन्स फ्रॉम एन टाइप विल स्टार्ट मूविंग टुवर्ड्स द एनोड. ओके, at the middle they may combine. Holes are having positive charge, electrons are having negative charge. They may combine and form a region that is called as depletion region, and that depletion region will work. Now when we are connecting it in forward bias, the current will flow. When we are connecting in it reverse bias, the current will not flow. So because of this property of the diode, that during the forward bias the current flows and during the reverse bias the current will not flow, we are utilizing this diode as a switch. स्विच में क्या होता है, करंट का फ्लो होता है, करंट का फ्लो नहीं होने देता, और यही प्रॉपर्टी यहाँ पे आ गई. तो डायोड को हम एज अ स्विच यूज करते हैं. डायोड क्या होता है, पी टाइप और एन टाइप सेमीकंडक्टर को मिला के बनाया जाता है.